All right, for the first one, what goes in this, what do you want to put in this fill in the blank slot? That you can't see. Huh. How about now? Yay. What do you want to put in this fill in the blank slot? Second? Movement? Okay, I'm okay with movement. Something else? I like speed. Yeah, speed. We're really like, if the temp goes up, what's happening to the molecules? They're moving faster. That's it. All right. Isotope, what's that one?
Different numbers of neutrons.
Okay. So, equal what?
Chemical composition.
Equal amount of protons and electrons.
So we're talking about two atoms that have equal numbers of protons, so they're the same element, say carbon, but they have varied number of neutrons. So it's still the same element, it's just one weighs more than the other. Allotrope?
And elements that pair with themselves.
So I've got an element and it pairs up with itself, and then given different circumstances, it might pair up with itself differently. So graphite, diamond, charcoal, buckyball, S8 or just S's, or O2 or O3. And the diatomics?
It's an element paired with itself.
It's always found paired with itself. This only applies to its elemental form, meaning you could have a single oxygen in a compound. It doesn't have to be O2 all the time. Water is H2O. We're talking about these 7 elements when they're found by themselves, just as in their elemental form, they're always found paired up. And those start at nitrogen, move over to fluorine, go down to iodine, and then include hydrogen. This 33 years, why the 33 years?
No one was looking for it.
One, no one's looking for it.
No one was looking for it, and two, it doesn't have a charge to be found.
Yep. Come on. There we go. Okay. How about filling in this table? What do I need? Beryllium's atomic number.
4
So if I've got an atomic number of 4, I have how many what?
electrons.
I have 4 protons, which means I have 4 electrons since I'm an atom. And then this guy's mass is 4, so this is beryllium. Okay, if I've got 80, if I got an atomic number of 82, what else do I know? What else do you know?
82
82.
protons.
82 electrons, because of 82 protons. Okay, what else? This is lead, which is Pb, and lead. And if this lead isotope has a mass of 207, then how many neutrons does it have?
125.
125. Okay. So if I'm element OS, what do you know about me?
76.
I have 76 protons, which means I have 76 electrons. And if this one has a mass of 190, then how many neutrons does it have? 114? And what element am I? Osmium. Okay, so if I'm radium, my symbol is Ra. Element number 88? Yeah. And if this radium has 138 neutrons, then I've got 226 as my total mass. All right. So what's the shape of the table based off of?
The way that certain elements react with others.
Okay.
Does that say share?
Yeah, share reactions like they're like the same kind.
Okay.
And they're in the same column. So everybody in the same column basically reacts similarly to each other. What's it not based off of?
The alphabet.
Certainly. Anything else? It's not based off of electrons. It turns out that the chemical reactivity is because of electrons, but the person who created the table did not create the table based off of electrons, because one, they hadn't been thought of yet, and two, when they did, he didn't believe in them. How many energy levels exist, and how does that relate to the table? 7, and there are 7 rows on the table. How many sublevels exist? 7. And then they're S, P, D, F, G, H, and I. How many electrons fit in an orbital? Just 2. And which sublevels are found in energy level 2? Why?
It can only hold 2 sublevels.
It has to hold exactly 2 sublevels, and the first 2 sublevels are S and P. How many electrons fit in that 4th energy level?
36. 2. 14.
Two, because don't you have to add them all together? Yeah.
There's an S, there's a P, there's a D, and there's an F. That's 2, 6, 10, and 14. We good with that? And so that gives us 32. And the Y is because the 4th energy level has 4 sublevels in it, and each of those sublevels could hold that many electrons. So you could fit 32 electrons in that 4th energy level. All right, that's it.